All right, welcome to day 3 and 4 notes here. We're talking about dividing segments proportionally, so it's a directed line segment. All right, we're also going to be talking about equations of lines and then the equation of the perpendicular bisector. So let's start it off. Number 1, dividing segments proportionally. So remember in this question, when we were talking about dividing segments proportionally or directed line segments, we were trying to figure out a point that was located somewhere on our line so that it was like 3/4 the way up the line, or it cut the ratio of the line into 3:2. Now, if we did 3:2, it wouldn't be 3/4 actually. So what we would be talking about is the fact that I have some sort of a line and I'm cutting it so I have 3 parts of the line over here and 2 parts over here. So that's 3 out of 5, 3 and 2 total parts. So this would be 3/5. All right. So when you see a fraction already written, you don't have to worry about it. But when you see a ratio, you need to turn it into a fraction. And it's the first number over the sum of the two numbers in the ratio. All right. And then all we did was we counted the rise and the run to get from point to point. Let's get rid of this for a second. So remember, we talked about going from -4 to 12. How do we get there? And you can see we would have to go over to the right 16 units for that to happen. And then we went up from 5 to 13. So this was add 16. And this is going to be add 8. Okay, you can see we're going up 8. So over 16, up 8. And then all we did was we took our change in x, which we knew was 16. Okay, I'm going to put equals here. And we multiplied it times 2/5, and that gave us our actual change, how far we actually want to go over, so that we're going over 2/5 of this distance, okay? And this would essentially be 32/5, which would be 6.4. So we would go over 6.4 units from -4. So if we add 6.4 to -4, that takes us somewhere over here, which is plus positive 2.4. And then we did our change in y, which was 8, and we multiply that times 2/5. And this is 16/5, which is 3.2. And so if we went up 3.2 units on this line, okay, and then we would just find where that point is on the line, and this part of the segment would be a ratio of 2/5 of that whole line. That's it. So we're going to walk you through, I'll walk you through a couple of these, and then I'll have you try one or two on your own here. So let's take a look at number 1. So what are the coordinates of the point that would divide the segment, given the endpoints, A and B, with a ratio of 4:1? So as soon as we see the 4:1, we got to think to ourselves that we have a segment. We want to cut it so there's 4 parts on one side of the line here, okay? And then there's one part, get out of here, on this side. So here's our 4 parts over here and 1 over here. And so this would be 4/5 of the total line. The first number over the sum. Okay, then we're going to do our change in x. So delta x equals. Now just look at the first 2 coordinates and the 2 points. How do we get from 2 to 7? And you would say, well, that's easy. We have to add 5. So we're going to take 5 and we're going to multiply it by our fraction here, 4/5. So 5 times 4 is 20, divided by 5 is 4, or we can kind of think like the 5s are going to cancel each other out here, and then we get left with 4. And then the change in y is going from 8 to 3. We'll do this in a different color here just so we can keep track. All right, how do we get from 8 to 3? We have to subtract 5. So the change in y is going to be -5, and we're going to multiply this times 4/5. So that's -20 divided by 5, which is -4. So nice and easy. We're starting with the ratio of 4. That's why we did 4/5 from the first point we started with here, okay? Because it went from A to B, ratio of 4:1. So the 4 goes with the first point. So we're going to take the first point, which is the point 2, 8, and I'm going to add the change in x to the x coordinate and the change in y, which is -4, to the y coordinate. And this is going to give me my new point. So 2 plus 4 is 6. And 8 minus 4 is 4. And my final answer is the point 6,4. That's it. Okay? All right. So let's try letter number 2 here. together, and then I'll have you we'll do the graph, and I'll have you try number 4 on your own. So number 2, same thing, going from A to B, we're partitioning the line. That's another way they could ask, and we see the ratio is 5 to 2. So remember, we're going to do the sum, the first number over the sum, so 5 over 7. Okay, and if you want to draw yourself a little line and cut it so that there's 1, 2, 3, 4, 5 parts here and 2 parts here, you know it's 5 over 7 parts. This is not like a 2, it's just like a squiggly line. All right, so once again, we're going to do our change in x. So how do we get from 0 to -7? We have to subtract 7. Times that by 5 over 7. All right, the 7s will drop out, leaving me with -1 times 5, which is -5. You can also think of it as -35 divided by 7, which is also -5. All right, the change in y is going from 10 to -4. So remember, we have to go from 10 down to 0, and then another 4 to get down to get to -4. So this is -14. So the change in y is -14 times 5 over 7. So you could multiply it out to get 14 times 5, okay, which is going to give us -60 and then divide it by 7. Or you could drop this out, 70. You could drop this out and get -2 times 5, which would equal -10. So -70 over 7, which is going to give us, I put 20, but it should be -10. All right. Now remember, since the 5 is first, that goes to point A, okay, here. So we're going to, and since we did 5 over 7, we're going to take point A, which has the coordinates 0, 10, and we're going to add these two numbers to it. So we're going to subtract 5 and subtract 10 from the x and the y coordinate. And so this gives us -5, 0 as our point. We should choose choice 3. All right, little bit tricky on this one. So 2 runners are moving towards each other on a road that is represented on the graph at right. One runner is moving at 1.5 times faster than the other runner. If the faster runner is located at -3,2, what point will the 2 runners meet? Now, the faster runner is located here. So that means that this part of the line, because it's faster, is going to be the larger part of our line. Now, the way this works is that 1.5 is technically 3 over 2. 3 to 2 is going to make a ratio of 1.5. So if we try to cut this into 2 parts, okay, it's going to be 3 out of 5 total parts. All right, this is the fraction of the line that we're going to be using. That's it. So we're going to start by, once again, counting the rise and the run. And you're going to have a graph, just like you're going to have a graph on the exam. You'll have a page you can tear out. So you can always graph these for yourself. So we can draw a line down. We can count 1, 2, 3, 4, 5. This is going down 5. And then we're going over to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And it's positive because we're moving to the right. Now, remember, our point is going to be located closer to this point, so further away. That's why it's 3/5, not 2/5. If it was 2/5, it would be closer to this point, but he's faster, so it's going to be a little bit further down the line. So once again, our change in x, and we have our change in y. And we're going to multiply those two things, 13, times 3/5. And our change in y is -5. We're going to multiply that times 3/5. All right, so 13 times 3 is 39, divided by 5 is going to be 7. That's 35, and it's 39.8, okay? And you can use your calculator, and you can also do that on there. So if you multiplied those numbers together, 13 times 3 over 5, you'll see you get 7.8. -5 times 3/5 is -15 divided by 5. That's -3. So once again, we're going to start from our fast runner, which is -3, +2. It looks like a negative that's blending into the line though. But -3, 2. And we're going to add 7.8 onto the x and subtract 3 from the y. So this is going to be 4.8. We subtract 3, 8. And this is going to be -1. Okay? So we'd say the runners meet, not runners, runners at the point 4.8 and -1. And that's it. So I'm going to have you guys try, we'll try number 4 on our own here. This is a little bit tougher. We're going to do this one together. So a segment has endpoints of -6,5 and 6,8. Tim found point T where the distance for -6,5 will be half the distance of point T, which is at 6,8. So if we kind of think about this as a line, okay, so let's just make a line. All right, here's going to be the point -6,5. Now, technically, our line, because it's going from -6,5 to 6,8, is going to kind of like go up a little bit. It'll be like slanted a little bit that way. So let me just redraw this real quick. -6,5, and then the point 6,8 is somewhere up here. So it's going to be like that. Like that. Okay? And these are the endpoints. And we want to find point T. Now, if we put point T right in the middle, okay, what that means is that this would be a ratio of like 1 to 1. If this length is x, this length is x, okay? But that's not what we want, right? We don't want the line to necessarily be right in the middle. We want to make it so that point T, the distance between -6,5 and T will be half the distance of T to 6,8. So we want to move this, okay, line so that it's half the distance. So that, in other words, if this distance is 2x over here, right, then this distance would be x. So this is half now of what this distance is between T and 6,8. So if you look at this, this is a ratio of 1 to 2. And so if we make our fraction, we do the first number, which is 1, over the whole line, which is 3, and we're 1/3 of the way up the line. So all we're going to do is do the same thing we did before. We're going to say to ourselves, what's the change in x? What's the change in y? And when we get that number, we're going to multiply it by 1/3. And then we're going to add it to the first point where the ratio is 1 to 2 from the 1 part. Now, to get from -6 to +6, we got to add 12. So 12 times 1/3 is 4. And to get from 5 to 8, we have to add 3. So we're going to take 3 times 1/3, which is 1. Okay? That's pretty much it. So we're going to take our first point, which we talked about was -6,5. And we're going to add 4 to the x, because that was our change in x. Okay? And we're going to add 1 to the y, and we're going to get the point -2, 6. So T has coordinates of -2, 6. And that is directed line segments. All right. Second part, lines and angles. So if we remember our parallel lines cut by a transversal, okay? As long as these two lines are parallel, we're going to have some angle pairs that are equal. Now remember, the short version of this was we said that there are a few types of angles. There are acute angles. There are obtuse angles. And there's a combination of acute, A-C-U-T-E, let's spell that right, and obtuse. So if you have two acute angles, remember that they are congruent. Two obtuse angles are going to be congruent. And if you add an obtuse or put them together, you're going to make 180. So when you look at the line, you can see that this is obtuse, this is acute, okay? This is obtuse, this is acute, this is acute, this is obtuse, and this is acute, and this is obtuse. So they kind of go against the grain here, all right, back and forth. So if the lines are drawn like this, it'll switch. That's acute, that's obtuse, this one's acute, okay? Acute over here, here's obtuse, here's obtuse, this is acute. So all the obtuse angles are equal, all the acute angles are equal, all around this stuff, okay? Now, formal vocab words. Corresponding means same position, okay? So if you look at the intersection that's going on here, let's draw this in one line. We talk about angle 2. When I move this intersection down here, notice what angle is taking the place of angle 2. It's angle 6, right? 2 slides down there, it moves on to angle 6. Those angles are corresponding and therefore equal. Those are the corresponding angles. So in the same position, top left, bottom right, top right. Those angles are equal. Notice, acute, obtuse, okay? They always match. Alternate interior. That makes our Z. That's the alternate interior. So if you can make a Z, all right, 3 and 6, alternate interior. And if we can make a Z go in this way, okay, 4 and 5, also alternate interior. All right. Alternate exterior are the ones that are going to be made on the outside. So you have to change sides of the transversal and change intersections. So 2 and 7, 1 and 8. And then same side interior, or, okay, the same side exterior. These angles are supplementary. So that would be 2 and 8. Notice acute, obtuse, okay? Those add to 180. Same thing if I'm on the inside, 4 and 6, okay? Same deal. These add to 180. Acute, obtuse, okay? So keep that in mind. So a lot of times what we're going to do for these questions is they're going to give you, for the part 1 questions, they'll give you some angle measures, and then they'll ask you to identify one of those angles or a different angle that you would be congruent to that one. All right, what I'm going to do for this one is, this is a typo here, so let's cover this up. And I'm going to fill in what it should be. So it should say L is parallel to M. If angle 1 is 2x plus 120, and angle 2 is x squared minus 6x, what is the measure of angle 3? So angle 1, and the way that I like to do it is I kind of like to label the question, what it's giving me for the angle measure, on the diagram, so I can really get an idea of what angle we're referring to. All right, and then angle 2 is here. It's x squared minus 6x. So how are these angles related? Now remember, if we make a Z, okay, we can see that this angle is the same as angle 2. So this is also x squared plus or minus 6x. So these angles make a straight line, and therefore they add to 180 degrees. So let's make our equation, and then we can determine x. So 2x plus 120 is going to equal, or we did it wrong, we said supplementary, adding to x squared minus 6x is going to equal 180. Now, as soon as we notice that there is an x squared in our question, that is automatically a quadratic, and we need to think to ourselves, all right, we're going to have to factor, which means the first thing we need to do is get this thing equal to 0, okay? So we're going to move the 180 over and combine that with the 120, and I also have some like terms with the 2x and the negative 6x. We're always going to go in descending order in standard form, so remember that it's x squared, 2x minus 6x is minus 4x, and 120 minus 180 is minus 60. Okay, now we're looking for numbers that multiply to negative 60, but add and subtract to give me negative 4. So if you walk through your head of negative 60, it's like 1 and 60. 2 and 30 doesn't work, okay? 4 and 15, not going to work. But 6 and 10 would work as long as, that's right, the 10 is negative. So we know we can do our 2 sets of parentheses because it's x squared. We would have to multiply x and x together. And now we know that there's a positive 6 and a negative 10 that goes inside. Okay, zero product property says if this thing multiplies to 0, either the first parenthesis is 0 or the second parenthesis is 0. So that's all we're going to do is set both of the factors. Anything that's over here, if it's by itself or on the outside, so if there's another x over here, we'd set all three x plus 6, and x minus 10, we'd set those all equal to 0, okay? I'm just writing this so we can easily tell it's a 6 and not a b. And then we would solve, so I would subtract 6 to get negative 6 on this side, and I would add 10 to get 10 on this side, and there should be an or in the middle here. So this is a minus 6, this is a plus 10, all right? And since we can't have a negative length, right, we know this is out, and this has to be our value of x. Now, careful, it does not say what is x. It says what's the value of angle 3. Now, angle 3 is right here. So it is supplementary to this one and equal to this one. So you could use either of these. Let's go ahead and plug in here. All right. So if we plug into 2 times 10 plus 120, this is 40 plus 120. This makes this 140. And so the angle 3 is going to have to be 40 degrees. Also, you plugged in here, 10 squared, right, is 10, is 100. 10 squared is 100. And then minus 60 is going to be our 40. And it's equal, okay? And so the measure of angle 3 is equal to 40 degrees. All right. There are a lot of questions that are similar to ones like this, where there's some crazy diagram involving the parallel lines and not necessarily these ones, though they do show up. So if you get a crazy diagram, make sure you identify when the lines are parallel, okay? And if there's anything else going on, and then use your z's to help you out here, okay? So angle 1, 63. Let's put the 63 in. We know this is congruent to the angle down here, so we can label this as 63. This angle, it said, was perpendicular, so that's 90. And then we're looking for the measure of our angle 2. So nice and easy. Just 90 plus 63 is 153, and then 180 minus that gives us 27. Now you could also look at this and say, hey, if this is 90 degrees, then these two angles have to be complementary and add to 92. So just 90 minus 63, and this is just another way to get the same answer, is 27. And so we know the measure of angle 2, depending on which way we pick, is just 27 degrees. All right, 22. Let's try this one on our own. You guys ready? All right, give it a go. All right, so starting with the two angles, 5x minus 22 and 3x plus 10. Notice that they are in the same position here, so those angles are corresponding. They're going to be equal. So we set up our equation. Okay, to solve, we're going to move that 3x over first, and then we can move that 22 back to the other side to get us 2x is equal to 32. Get rid of that 2. We'll get that x is equal to 16. 16. And then just remember, it says the value of x, not the value of an angle. So 16 is the answer. Okay? And that's it, and we are done. Next part of the lesson was on equations of lines. And if you remember, we were a big proponent this year of using the point slope form. Okay? So in the point slope form, remember that the given point, the point we know, okay, point we know, is going to be listed as x1, y1, okay, and the slope is going to be m. Remember that as you plug the point into the equation, make sure we change the sign because it's a minus there. So as you plug the point in, make sure you change the sign. Okay, slope intercept form of line is y equals mx plus b. So xy is just some generic point. We're never going to plug, we're never going to change that in the equation. We just have to plug in m and b. So remember that after you plug in the point and the slope, you'll have your point slope form. And if you need to get it in y equals mx plus b form, you can just go ahead and distribute through and then move that 3 to the other side when you're done. That's all you're essentially going to do to get it into this form. And remember, in this case, that the slope for this one was negative 4. So this should be a negative 4 here in that answer. I just forgot to put the minus sign. If they give you 2 points, you need to find the slope first. So you're going to have to do this first. So remember, we said that slope was equal to either rise over run, change in y over change in x, or y2 minus y1, x2 minus x1. Remember, we normally looked at the points and we just called the first point x1, y1, and the second point x2, y2. So when you see the y2, you're just thinking y coordinate and the second point, okay? So that's the 4, not y squared, all right? And then you're just subtracting, you're reducing, negative 2/3, and then we're slope, we're picking one of these 2 points, and then if we need to distribute, we'll have our final answer. Okay, last thing, and we'll come back to this, perpendicular bisector. If it tells you the lines are parallel, remember the slopes are the same. And if it mentions that the lines are perpendicular, okay, that means that the slopes are opposite or negative reciprocals. So if there's a fraction, we're going to flip it, and then we're going to change the sign. All right, if it's not a fraction, we'll put a 1 under it and then flip it. All right, we'll do a couple questions. Number 9 is not a question they typically ask. I just wanted to bring it up in case they do ask a question about, like, these 2 lines are parallel and this one's perpendicular, like what's going on. So just draw yourself a picture in most cases. So if we had a line, well, we got 2 distinct lines, L1 and L2, and they're both parallel to a third line, which we'll do in blue here, all right, which is L3. So L1 is parallel to L2, all right, and L2, interestingly enough, is parallel to L3. What do we know about these lines? And hopefully we notice that they are all parallel to each other. That's it. Now, it could also phrase it differently and say that they are L1 and L2 are parallel, and L1 is perpendicular. Wow, that is not what I wanted to have happen. It's perpendicular, so if it goes this way to this line, and these lines are parallel, what's the relationship between, let's say, L4 here and L2? And if these are perpendicular and these are parallel, this would also have to be perpendicular. That is a question that they could possibly ask that might show up. So just keep that in mind as you're working along. Draw a picture and then see what you can notice from there. All right, number 11. What is the equation line that passes through the point Q4 and is perpendicular to this equation? So key thing, perpendicular means we're going to have to find the slope and then do the opposite reciprocal. Now we need to get it in this form in order to determine the slope. So solve for y first. So we see there's a 3 here. We want to get rid of that first. So y is equal to 2x plus 1. And now that I see what the slope is, I don't care about anything else on the line, okay? I see that the slope of this line is 2, but I'm looking for a perpendicular slope. So if you think about it as 2 over 1, it's change the sign and flip the fraction. So negative 1/2 is our slope. Also keep in mind that this point we are calling x1 and y1. So when we go over here and do y minus y1 equals m times x minus x1, we can just substitute into the equation. All right, now this is not on the formula sheet. You're going to need to remember this one. Okay, y minus y1 equals m to x minus x1. Okay, so all we're going to do is place in the y1, x1, and the m. That's what we're plugging in here, okay? y1, m, and x1. So let's do it. So we're going to say y minus y1 is 4 equals the slope, which we said was negative 1/2, and then x minus 2. Now we would want to check, okay, does it match any of these? And we can see that these are in slope-intercept form. So all we have to do is distribute to solve. Now, I think I copied something wrong here. I kept this as 25 over 2, but as soon as I notice that this slope is negative 1/2, I can immediately kind of eliminate some of these choices. So this is 2, this is 2, all right, this is 1/2 x, this is negative 1/2 x. So I would immediately circle this one to know that it's the same. There's an error here somewhere because this does not equal negative 25 over 2. But we'll just go through and work on it just so we can see what happens. So I'm going to get y minus 4 equals negative 1/2 x, and then half of negative 2 is positive 1. And then I'm going to add 4 to both sides, and I would get a final answer of y equals negative 1/2 x plus 5. So I think there was just a typo with this when I carried it over. All right, and that's it. That was your final answer. Okay, so what I would normally do is once you find the slope, You can eliminate any choices, and then, if you get stuck, this is the 50-50 guess from there. All right, number 12. If we look at number 12, we're going to do the same thing. This time it's parallel, okay, and we have to get y by itself first. So if we do 2x minus y is equal to 4. Now, what might be easier to think about is what if I just move the y over here? Now it's positive. So 2x equals 4 plus y, and then move the 4 back. So I get 2x minus 4 is equal to y. Now, that tells me the slope of our line is the number in front of the x. It's just 2. So these options are gone. And now I just need to figure out which one these are. Now, if you had a calculator, and you do, there's an easy way that you can check this without having to do any work at all. And while this loads, we'll go over and off to the side and we'll start solving. So remember, we're going to do y minus y1 equals m times x minus x1. Okay, from our point, the y coordinate is negative 11. So y minus negative 11. When we plug a negative number in, it changes signs and becomes positive. The slope is 2, and we get x minus and then negative 3. So change that sign so it's positive. And because these aren't in point slope form, we're just going to distribute and then move that 11 over. So y plus 11 equals 2x plus 6, and then minus the 11 from both sides to get y equals 2x minus 5. And there's my answer. Now, on the calculator, okay, we can just type these equations in and check the table to see if it goes through our point. Okay, so we go menu, graph. Our equation here was 2x minus 5. So this is the same thing as y equals. And we can check our table, and we know the point is negative 3, negative 11. So if we just go to negative 3, does it say negative 11? If it does, that's our answer. That's it. Just make sure the slope matches, and then you can pick that line that has the same point on the line. Okay? All right. Question 13. Now, they want to know, how are these lines related? Okay? So number 1, collinear is basically a fancy way to say they are the same line. Okay? They have the same slope and the same y-intercept. Parallel, remember, means that they have the same slope, but the y-intercept is different. Perpendicular means they have opposite reciprocals. And intersecting but not perpendicular just means that they have any other slope, okay, anything else. All right, so we already know that this is in point slope form, so this slope is just 3. We don't have to do any work for it. However, we have to do a little bit of work over here. So let's go 3y minus x is equal to 3. We can go ahead and add x to both sides. We're going to get 3y is equal to x plus 3. And then when we divide by 3, remember there's technically a 1 in front of the x. So this is 1/3 x plus 1. So we notice the slope here is positive 3 and positive 1/3. So they're not, this is the problem, they're not opposite reciprocals, there's just reciprocals. So that's not perpendicular. They're not the same, so they can't be 1 or 2. So it has to be choice 4. All right. Okay. Same thing with number 14. So see if you can try number 14 on your own, and we'll take a look at it together. Let's go ahead and pause it. Try it for yourself. All right, and hopefully you picked choice 4. So let's take a look at it. So number 1, remember we started with this crazy equation here. That's in standard form. We're going to have to go ahead and solve for y first. So if you do solve for y, move that 4x over, divide by 2, you should get negative 2x plus 7. So the slope is negative 2, which means we can eliminate choices 3 and 4 because those are slopes of a half. Then we're going to plug into our point slope form over here. So we're going to plug in the negative 2, the 2 for x, so it should be y minus 2. So we're plugging in 2 for y1, okay, times negative 2, x minus 2. We can go ahead and distribute through to get negative 2x plus 4. And and then move that 2 over to end up with the negative 2x plus 6 in our final answer. All right, number 15 is in point slope form, so that works for us. And we want to go parallel to this line, okay, key thing, all right, and passing through point P. So remember, point P has the coordinates of 3, negative 2, so keep that in mind. So if I plug 3, negative 2 in, I can kind of already get a gauge that the y coordinate should be y plus 2. So it's not going to be these ones, okay, y plus 2. And the x coordinate should be minus 3. So the question is the slope 2 or negative 1? And all we have to do is look to see where the whole number coordinates are for this point. And how do we get there? You can see we're going up 2 and over 1 to the right. And so our slope, rise over run, is just 2 over 1, which is 2. So we know the answer is going to be choice 2 and not choice 4. All right, very last topic of the day, going back to the first page here, is, I should say, third page here. All right, finding the equation of the perpendicular bisector. So the perpendicular bisector means I'm going to be given a line, and I'm going to ask to figure out what the equation of a line is. That A bisects the line, so it has to cross through the middle. So where the midpoint is, that is where the line is crossing, and it has to create a 90-degree angle to be perpendicular, okay? So we know that these two lines are also going to be perpendicular. So we're looking for the perpendicular slope and the midpoint, and then we're going to plug that into either our y equals mx plus b formula or our y minus y1, which is what we're going to use, equals m times x minus x1 formula, okay? So we got to find the slope of the perpendicular line, the midpoint, and then we're going to plug those in to our point slope formula to solve. All right, so let's do it. So negative 1, 1 is here, and then 7, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Here's 7, negative 5. So if we were to connect these points with a line, we can do that with our first cell. All right, and we want to create the perpendicular bisector here. So number one, we need to know where's the midpoint. Now, two options. The midpoint formula is x2, it's the average, right? We want to think about average. So add the x's, divide by 2, and then add the y's and divide by 2. All right? So if I take the x's, we're at negative 1 plus 7 over 2, and then we're at 1 plus negative 5 over 2. So this is going to be 6 over 2, which is 3, and this is going to be negative 4 over 2, which is negative 2. So 3, negative 2, there's our midpoint, and you could have also just figured out that you're going to drop down 6, so instead of going down 6, if you only went down 3, you'd be in the middle, all right, and then we'd be going over, all right, 8 spots. So if you only went over 4 of those 8, then you'd be able to find from those two values where the midpoint is. So you can kind of keep that in mind as you're working along here. Can't think about dragging that up here. Like that. Down 3, over 4, halfway, there's my point. All right? Now, the other thing we need is we need the slope. So remember that the slope on the graph is also considered to be rise over run. So we're going down, right? 1, 2, 3, 4, 5, 6, and over 8 to the right. That means the rise is negative 6, and the run is 8. We get a slope of negative 3/4. But remember, we want the perpendicular slope, which is to change the sign and flip the fraction, so that would be 4/3. Finally, we want to go a line that has our perpendicular slope and crosses through the midpoint of our line, okay? This just means that these all should have midpoint in front of them. So all we're going to do here then is do our y minus y1 equals m times x minus x1. And the beauty is we just have to plug in and we're done. So we're going to do y minus the y coordinate, which is -2. So y minus negative turns into a +2. The slope, remember, was 4/3. And then it was x minus the x coordinate, so x minus 3. So final answer, y plus 2 equals 4/3 x minus 3. And if you wrote this on the exam, this would give you full credit. Okay? And that is it. You are done. So, thank you guys for sticking around for this one. I do apologize that the sound quality was not exactly awesome on the first one, so hopefully this makes a little bit more sense. And then tomorrow, when I see you guys, we'll be going over a bunch of questions that relate back to what we learned, what you guys did in class the last 2 or 3 days here. So, all right, so have a great rest of your day. We'll talk to you tomorrow.